You guys didn't have an answer for it. That was not good. To an extent. To which extent? You guys not really get the vibe? You all know they're like you guys, right? Okay, cool. Well, if that wasn't clear, I do like you all, just so you know. Ugh. All right. So here we go. Help me find the critical values. When we factor this, what are we going to do first? T and it leaves behind T minus 10, which means where are my critical values? What time? 0 and 10. Now, because I only have two of them, before I put any on the number line, because I want to make sure that they are aligned together, but I only want to put the dashes on the number line. Let's do the same for the second derivative. When I set this equal, what fact? Well, I guess I don't really have to do anything. What's the only t value? 5. It's a 2 and it's a t minus 5, right? So we get t equals 5. Okay. Once we have these, I'm going to put these on my number line, and I'm going to try to do it as to scale as possible. So here we go. Realistically, we don't need negative time, but we'll survive here. I'm going to put 0 here and 10 here. Now, if you want to put the other one on, you can, but I'm going to do it on this other number line down below. So here we go. There's a 5, and notice 0 and 10, 5's right in the middle. I'm not going to be perfect, but I'm going to try to at least make it believable. If I had a bunch of zeros, I might copy some of them over, but it's really easy to lose track if I get a ton of information here. But if it is drawn to scale and they're at least reasonably believable, this is going to go pretty well. Now, I noticed that both of these roots showed up one time, which means multiplicity is in effect here. Now, if you don't love it, that's okay. I split velocity into 3 different intervals. What's one of the, like, give me any value in any of the intervals here. So it could be negative, or between 0 and 10, or bigger than 10. 1. And sorry if I didn't hear you. Now, notice, I'm going to write it here. I'm going to do it in green just so it stands out. I'm not going to put a dash on my number line. I won't do it. Okay, so if we plug this in here, and I'm plugging into velocity, and I don't care whether it's on this one or it's in the factored form because they're both velocity, let's just see what we get. 1 times a negative 9 is a positive or a negative? Negative. So I plugged it in here, and I just did 1 times negative 9, in case somebody's not clear. Negative. What is it over here then? Somebody confidently whispered positive. Can you convince me? How did you know positive, whoever it was? Love it. She said because the root showed up 1 time, and that means an odd number of times, and thanks to multiplicity, I know that it crossed the x-axis, and now it must be positive. Great answer. Okay, how about 0? What is it on the other side in negative time? Positive. Now, it's weird to think about negative time, kind of, but is it possible that, like, right now I'm already moving, and I have some velocity, and then now I start the timer, so that negative 2 seconds does make sense because it was 2 seconds before I started. Like, negative time is okay, depending on the context. Okay, so we got these. Let's deal with the second derivative now. There's only 2 intervals. What's the easier value? Or what number do you want me to plug in here? A 1. I'm fine with that. I can plug in a 1 here as well. So we'll do it. And let's look at acceleration. If it's 1, what's acceleration? Negative. And if it's 6, then it must be positive. Okay, from this, we have everything that we need. Now, what I want you guys to do is you're going to try to help me. We're only going to look at 0 onward because although negative time might make sense, we're only looking past where we started recording our data. How do I know if something's speeding up or slowing down? So careful. I think that you answered, how do I know if we're moving to the right or left? Because you're looking at the sign. But can I be speeding up to the left or speeding up to the right? And it's what's true about velocity and acceleration? When the signs are the same, I speed up. When the signs are opposite, I'm slowing down. So let's just go ahead and we're going to start writing this. Since this is our total question, we're going to write our answer in the context. The particle, and then we'll make sense of it. The particle. Is that what we're dealing with? Or an object? I'm going to change it to particle for now just so I don't have to erase it. The particle is speeding up for time in some interval. And then let's answer this question. So we are going to be speeding up for some range of times. Now, it's when both the signs are the same. And let's see. I'm only looking to the right of 0 for this. When I start velocity, what's its sign from 0 on immediately? Negative, right? What's acceleration? They're both negative from 0 to where? So negative, 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 negative to here, right? So if they're both negative, I'm speeding up. All right, so I'm speeding up for time in the interval from 0 to 5. Now, if we wanted to be really specific, I'm speeding up in which direction? I'm okay with negative. I'm gonna put this comment here to the left, and it doesn't have to be part of your answer necessarily, but it's nice. How do I know it's to the left? What's negative? Good. So velocity is what I really care about to know which direction I am moving right now. Because velocity is negative, I must be going left. Cool. Are there any other places where it's also speeding up, but maybe to the right? And for t in, and we could have done a union here, but I'm separating it so we can make sense of the left and rightness. Another place where both of them agree in sign. Ten to infinity. Now, if you're struggling to see this, and I'm just going to highlight it here, I wouldn't draw this all in yours, but as we look at too bold, as we look at this section, they're both negative here, right? So I'm speeding up. On this section is where they're both positive. That's how we just got our answers. I'm just comparing my two number lines. And I'm looking for where they're both the same. Now, that leaves this whole middle range where velocity was negative and acceleration was positive. If they're opposite of each other, what's it doing? Slowing down. So we'll just say, and I'm going to do the same thing. From 10 to infinity, if velocity is positive, which direction am I moving? To the right. I agree with you. Okay, so the particle is speeding up on those regions. Where's it slowing down? And slowing down from 5 to 10. Good. For the times that are in the range from 5 to 10. Now, last little question. What direction is it moving as it's slowing down? And how are you thinking about that? Because it sounds like such a challenging question, but there's a super easy answer that Fern, I don't want you to shout this one just because I think that you and I think you saw it on the first one. Maybe not. Talk with your neighbors. What direction am I going when I'm slowing down? Sorry. Left. Why? The velocity is negative. I must be going left. Now, I am going left, and I'm slowing down, slowing down, slowing down until I do stop, and then all of a sudden I start moving right. I can't go from moving left to right unless I stop, and that only happens when the velocity is 0. Okay, doable? Should we do one more? Okay, let's knock out one more. Here's the deal. How many of you guys are leaving for Christmas? Anywhere, like, so a few of you. How many of you guys, whether you're leaving or not, have access to a phone with a camera that you could email me something before the start of the next semester? Okay, so here's what I'm thinking. I'm going to hook you guys up solid here. I am more concerned with, can we get through this stuff? Because I don't want to leave us hanging at the end of a chapter. That sounds like an awful idea. Right now, I think we're going to finish the entire lesson by tomorrow, maybe. It depends. Worst case scenario is it pushes to Wednesday, which means if we don't finish a lesson until Wednesday, do I have time to give you a formal test in class? No. So what I'm proposing, and you guys let me know, is if I don't have time to give you a formal test in class, and I don't want you to forget calculus over the break, we could probably kill two birds with one stone here, and I'll just give you a test that you need to take with you and complete over the break, and email me a picture on an agreed upon date so that I can grade them and put them in before the end of the semester. What's up? So I have to submit my grades January 9, which means realistically by the 1st of January or by the 5th of January. Like, we'll work out the due date if this happens. Whether it happens or not, since I'm already suggesting it, I'm just going to let you guys take the test. So, JJ, that's easy for you. You'll just take it with you and complete it. Cool. You have to email me a picture of your test before, and I'll tell you the date on the test, okay? Cool. Does that sound reasonable? I don't want to rush this stuff and then make you take the test because this stuff is also equally important. And everybody's grade could probably use a little bump realistically. Merry Christmas. Happy Hanukkah. Kwanzaa. Really? You guys didn't know I liked you? Okay. It'll still be a test grade. Absolutely, it'll still be a test grade. Cool. With the understanding that I need to see your work. I don't want ChatGPT can probably do this test. Don't care about ChatGPT. I want your work, which means I need to see all of your work that you do. There's not going to be any restriction on what you can use, right? Because resources are going to be open. It will be cumulative, just so you're aware. It'll be this stuff focused primarily, but I'm going to give you problems to keep you busy over the break. Cool. Take home test. Let's bump up your grades a little bit before the end of the semester. I do like you guys, just for the record. That's like, I'm going to tell Mrs. Holloway about this like 1,000 times this evening. Cool. All right. So let's do another problem similar to this. And I kind of like these ones. Let's do one last little part of this. Last piece. And we're going to add to this. And we're going to call this part, was that delta that we just did? Just kidding. We only did A. Okay. So as a follow-up, this could show up on the test. I don't know if it will. We're also going to draw for ourselves a motion diagram. Now, it's still in this example, just so you're aware, but we're going to draw a motion diagram to see what's happening here. And these things can be challenging. It's conceptually challenging, mathematically not terrible, but oftentimes the applied part's harder. So we want to look at two things. We're going to try to make a motion diagram for position first. Now, all that means is when I follow all this stuff, what is happening with my position? So it's nice to assume at time 0, where should we theoretically, where should we start at? If here's my position function, at time 0, where am I? And I said, here's my position function, then I threw like 30 things up on the board, right? We started with position. At time 0, what is my position at? -10, right? Because 0 minus 0 minus 10. So I'm going to put a number line here, and we're going to do a little bit of thinking with this. I need a number line where we have position. And I'm going to put a few values on here. Might as well put 0, just naturally fits here. We'll put it right in the middle. And then we get -10, and we're just going to see where we wind up. Now, I'm going to not put it all the way at either end because I want to make sure we can see what happens. We get to do a few things here. And these things, I doubt it'll show up on the AP test, but it could. That's hence why we're doing it. But it's nice to see just this little physics application. When I think about this object moving, and I'm going to scroll up just so I can see these other ones. For the first 10 seconds, what am I doing? Which direction am I moving? From 0 to 10. I'm moving to the left, right? So all we're going to do is we're going to put our particle, our object here, and we start moving to the left. Now, eventually, we move to the left, and at 10 seconds, we turn around, right? Because my velocity gets to 0 and then changes positive. This is the weirdest thing we do. We're going to turn around. Now, I know that we're going into a second dimension. Like, it's strange to do this, but this is what we have to do if we don't just want to have the same bar just going back and forth. At what time did this happen? So we'll just make a comment. Here's where I turn, and at what time did that occur? I'm moving left until when? 10. So that occurs at 10 seconds. Now, the only other thing that we might need on this is, could we possibly find our position after 10 seconds? Like, you guys have it on your page. I'm not going to scroll here, but do we have a function that tells us the position at any given time? With your calculator or with your brain or a combination thereof, find me S of 10 from the original position function that we started with. Because I want to be able to put something on my axis here to say how far did I go. What is my position at 10 seconds? So here's my position function, and I'm just thinking, that's 333 minus 500 minus 10. So negative 167, negative 177. I don't have a calculator handy, so I don't trust my number. It's a decimal? Because you have a 1,000 over 3. Oh, so 333.3. I don't know. What do you guys get? Negative 176? So here it is. What I would type in, there's a few ways you can do this, Riley. You can either go into y equals, or since we're just doing it here, I would just type 1/3. What's 10 cubed? Minus, no, you're good. That's what I'm typing into my calculator, except it's minus 10, not 100. Okay, we get negative 176. Okay, is my scale good? No, Delilah just smiles rather than politely saying, no, it's terrible. That's okay. I don't care if my scale is good or not. I can tell how far to the left did it go. So here we started. We went all the way to negative 176, right? So 166, whatever's to the left, whatever they are. Okay, and then I go this far forever, right? Now, here is our motion diagram. This is all it's telling me. What time did we start with that might be worth noting here? So that's our position. That's our negative 10 meters from 0. What time is this? When would one start recording? At what time? So check it out. I'll stand here. So I'm roughly 10 feet away from there. So I'm just assuming that's 0. Here I go. I'm about to start. I'm going to start walking, okay? What time is it right now before I start? Oh, okay. So it's just 0. Now, in this, there's a few different things that we can work out of this. I don't know what time it happens, but I could track and I can use this to see, like, at any given point, where am I located, right? That's what the position function does. There is a time, and I'm just going to not say what it is right now, but there's a time where this happens, right? Where I get back to that. Last little physics connection that we're going to make. From, I don't know what this time is. We could set position equal to negative 10 and get the other solution out of it, but I'm just going to say it exists. I don't really care what the number is. I can make up a number if you really want. Okay, so here's my question for you. Whatever time this is, that blue dot, what's my displacement? How far am I from where I started at this blue dot, distance-wise? 0. My displacement is 0 because notice I started at negative 10 meters or feet, whatever it is, and I ended at negative 10. Haven't moved at all, displacement, haven't been displaced. What's my total position or total distance that I've traveled, though, and is it different? I went 166 this way, then I had to walk 166 back, right? Are we all agreed that I'm at like 322? Is that the right number? 366 and 366? 332? 352? But did you do the 66? Because we already started at negative 10. So 166 times 2 is the distance that I've had to travel here, right? Cool. And it's 332? 352? Okay, that feels better. So even though my displacement's 0, I've walked a total distance of 332, whatever they are. Awesome. These applications, I don't know that I would expect this, but we could do them. Okay, so because we've shifted and I'm giving you a final to take with you, here's what I'd like to do today. We can do another problem if need be, but I don't know that it's as necessary as you guys might think. If I'm wrong, then so be it. There's a first time for everything. As we look at it, I'm going to have you guys do a few problems for me so we see if we need more clarification on it. So for right meow, we're going to knock out homework 4.4.2. Is that true? Have we had? Yeah. Okay. And you will find this waiting for you. I don't know the page number, but it's 327-ish. Probably actually 325. And I want you guys to do problems 27 through 31. Odd. I'm going to ask all my other classes today because if you guys don't think or didn't know that I liked you, everybody else probably thinks I hate them. Ooh. All right. Let's see if there's issues with it. If there are, we'll sort them out. We'll work through them together. Tomorrow or later today, depending on how this goes, I have no idea how long it's going to take you. If we get a new start on it, we're going to start the last section of 4.4. Yeah, that's fine. Cool. All right. Just going to pause it because we'll see. I might resume. So on the assignment, I'm going to hook you guys up. And Rafa and Sean, if you guys have not started or not, or I guess if you haven't started, I would try before you just commit to doing this. But on 27, hook it up. What do I have? S of t, I assume, is given. And what's a position function? Just that? Plus 2. Thank you. 3. All right, now the thing about this is if you read all the directions very carefully, I don't have it open in my book in front of me right now, but they say work with t is greater than or equal to 0. So my number line doesn't have to go forever. It's just 0 onward. Same situation that we considered just now. So part A says, let's find when this thing moves left and right. Now, to know what direction it's moving, all I need is its what? Its velocity. So here we are. If I want the velocity in terms of t, do you need me to talk about it or can we just write it? Did you get 2t minus 2? Okay. And the critical numbers then, I don't know why my 2's came out different. The critical numbers happen where? Critical at, I think it's just 1, isn't it? T equals 1. Because if we set it equal to 0, we add 2 and divide by 2. Okay, so there it is. So if we want to put these on a number line, we can, and we probably should. We might have to draw this number line again, but let's check it. What number goes on here? And I'm actually going to make it a number ray instead, which is a weird idea. Why am I making a number ray instead? It says what? In the directions is why I'm changing it from a number line to something else. Greater than or equal to 0. So here's 0, right? Then the only other value that I need on this is 1. Okay, I'm going to pick something out here so I don't have to think about fractions. I don't know. If I plug in a 10, it's positive, which means I know it's positive here. And by that multiplicity idea, it must be negative here. So check it out. I would encourage your sentences, if you're practicing to make sure it becomes habit, that'd be good. But I'm just going to answer it without the appropriate notation here, just so we can have time to work through it. When's it moving to the right? For all t in some interval. 1 to infinity, unless they give me an upper limit on time, but I don't have the directions in front of me. They just say greater than 0, right? Okay, so there's where it's moving right because v is positive. Where's it moving left? For all t values where? Love it. There we are, 0 to 1. Okay, bravo. I have no idea what it's asking. Ooh, when does it go from moving left to right? At 1. That's where I go from moving left to the right, because that's the only place where my velocity is ever 0 and then changes signs. So we'll just say at t equals 1. And I can tell that just from this number line. Charlie, what does it want? Ooh, where the velocity, does it say velocity or speed? Interesting. Where the velocity increases and decreases. Now, my gut, if you read through Delta, Echo, and Foxtrot, do they ever use the word speed? So I kind of hate it. I'm going to double check it. I just want to read the exact problem. This is page 325. I just want to read it to make sure that we're not missing anything goofy. An object in rectilinear motion moves along a horizontal line with the positive direction to the right. The distance is given by whatever. Okay, when does the velocity increase or decrease? Okay. I hate the way they word that question. Can you tell why I'm hung up on this wording? If they said speed, I would know for sure whether they mean negative and negative or positive and positive. But because they only say increasing, more negative is not increasing. Do you agree with that? Like the absolute value of it is getting bigger, but it's definitely not getting bigger if it's getting more negative. So that's a weird little idea here. But I do need to check something. If I want to be able to talk about its velocity, what do I need to be able to do? Say it again. Hey, we probably need acceleration to be able to talk about it. So let's get that. And I'm going to switch to, I lied, I'm going to keep it orange. Well, let's do acceleration. A of t. What is acceleration? If this is velocity, 2, which happens to always be what? Positive. Now, instead of doing another number line, which you certainly can, I do just want to introduce to you though, because I don't really care how you do it as long as you can keep stuff organized. If I had this exact same number line, which there's my velocity one, I think reasonably I could do acceleration up above. And I could do them on the same number line if you'd rather do this. Now, what gets weird about this is it's always 2, right? Which means from 0 to 1, what is acceleration? Positive or negative? That was mine. That's my bad. What is acceleration's value? Is it positive or negative from 0 to 1? Positive, because it's 2, right? It's always positive. And it's also positive here. If you would rather separate it on a single number line, that's okay. It's no different than if I drew A below and I just said, oh, it's always positive. I get the same output. But when I do it on a single number line, I just make sure to have the sign assigned, like weird language here. I make sure to have the sign in every interval. So we might have to split it up a little bit more. But here we are. Maybe that question was not poorly worded. When is it speeding up, or when is the velocity increasing? Now, if velocity is increasing, this is a weird idea. I'm walking in the positive direction right now, yeah, for you guys. But if I walk negative, okay, so let's say I'm going to start going here. This is a weird question. Am I increasing my velocity right now? It feels like such a weird question. Am I increasing it? So you say no, but is it getting more negative or less negative? It's getting more negative as I do this. So here we go. Here's my initial. Okay, here I go. I'm going to the left, and now I'm still going left. But is my velocity getting closer to 0, or is it getting further away from 0? I think I'm getting closer, right? Because I'm slowing down. Do you agree that slowing down, my velocity is increasing? And it's a weird idea because we get velocity and speed goofed up. My speed is definitely slowing down, right? But positive velocity just means positive, like further to the right. If I'm slowing down in the negative, like I'm going negative, but I'm slowing down, is my velocity getting closer to 0? It's a super weird concept. Can't tell if it's clicking or not. My guess is no. Let me see if I can rephrase this. if I have positive acceleration, is my velocity going to get more positive? No matter what. Like, even if it's already super negative, I start adding and getting it closer to zero, and eventually it keeps going and gets big positive number eventually. I think I can see that in this situation, my velocity is increasing everywhere because my acceleration is always positive. And it's a weird idea because we have to parse between velocity and speed. Here, am I speeding up or slowing down? With positive and negative. Notice I'm saying speed. Slowing down. So let's just pretend I don't have a number here. I guess we could get it, and we'll just check. Let's check at a quarter of a second at 0.25. My velocity, and I'm going to try a half second because it's going to be nicer. At a half second, my velocity is 1 minus 2. It's negative 1, right? What about at 3/4 of a second? 2 times 3/4 is 1.5. So I'm now to 0.5 instead. And if I go further, is it going to get closer to 0 or more positive, further to the right on a number line? So we're speeding up, even though, or sorry, my velocity is increasing, even though my speed is not, because there's a distinction between those two. If my velocity gets more positive, or if you'd rather word it, less negative as I go, my velocity is increasing. And it's a super weird idea. Where's the acceleration positive here, though? From 0 to where? Where is acceleration positive? From 0 until infinity. So as we're looking at this, I can still tell that that concept did not click. So we're going to make a little table to make sense of it. Okay, so we're going to make a small table here. And this is way more than you need to do, but to get the concept down, worth talking about. We're going to make a table. We're going to have time, we're going to have speed, and we're going to have velocity. And we only need a few values out of this. Okay, so let's pick here real quick. At 0, what is my speed? Or we could switch these around. We can do velocity first if it's easier for you. Let's do velocity first. At 0, what is my velocity? -2, right? Because 2 times 0, it's -2. Okay, so I'm going to make that there. What's the speed there, though? Velocity is a vector, which means we need direction and magnitude or size. Speed doesn't matter. Do you agree that whether I'm going left or right, my speed is 2? Velocity just tells me what direction. So there's that first part. Let's do another one. Let's try 1/2. I don't know why I did that. 1/2. What is my velocity at half a second? If we plug it in here. -1. What's the speed? 1. Now, this in its own might be able to help us, but let's get one more point here. We'll make sense of this. Give me one more value. I guess we can do, I don't know, we could try, let's try 1. At 1, what is my velocity if I plug it into this lovely function? Everybody agree it's 0? And my speed is 0. Now, for this, I think that this table will be enough. This is a mathematical justification because it's a weird thing to talk about. Forget about the speed column right now. Is my velocity increasing or decreasing? If it goes from -2 on the number line, and then goes to -1, and then it goes to 0, do we all agree that I'm working to the right? I am increasing here. So for this, I'm just going to note underneath, velocity increases. And even though it was negative, it's getting less negative. That's like me slowing down as I'm walking across the room. The velocity is increasing. What is my speed doing? It decreases. So there is a very clear, I hope, distinction between velocity and speed. What we're working out with this is anywhere that my acceleration is pushing positive, it's trying to push me to the right. So whether my speed is increasing or not, doesn't really matter. Does my velocity ever stop getting bigger as I pick up bigger and bigger time values? Like it's going to keep getting bigger, right? If I plug in 10 to velocity, I'm now at 18. If I plug in 100, I'm now at 98, and so forth and so on. So we see that this increases when acceleration is greater than 0. How about speed? When do we say that speed increases or decreases? It's when something about velocity and acceleration. So when the signs are different is when my speed is changing. Acceleration positive means my velocity is increasing, always. So to answer this question then, we'll say this is for all time from 0 till the end of time, if this position model works for it all. Okay, it's a weird distinction. Did that make it more clear than me walking and saying the same thing over and over? It's still a weird idea. If you need more, let me know. I'll come up with another way to talk about it too. All right, what is Delta asking us? Draw a figure to represent the motion of the object. You got it. So here we are, Delta for draw, I assume. Okay, what time do we start at? 0. So let's go ahead and say here's position. At time 0, what is my position? 3. So here's where I start, t equals 0, and we'll just jot that down. What direction do I start going immediately? According to this, do I go left or right for the first second? I heard both. My velocity is negative from 0 to 1, right? So which direction should I go? If velocity is negative, am I walking to the right or to the left? So I'm getting a lot of blank stares here, but I feel like we've done it. Right now, am I going to your right or your left? Am I positive or negative velocity then? Positive. So if the question is, where do we start going? Do we all agree that I start going negative velocity? What direction do I start going then? To the left. And I go left until 1 second. We don't have time to put in the real numbers, but I think I go left like this to some value. Here's time equals 1. I don't know what this distance is, but you guys can calculate it out at that 1 second mark. What's our position? Cool. I'll see you cool cats tomorrow. I'm here at lunch. I'll be here for a few minutes at least after school if you want to come get some help with anything. Cool. JJ, I'll have your test for you before the end of the day. Cool.